The Delaware Valley is one of the highest volume oil ports in the U.S. and a critical environmental habitat. Therefore, minimizing disruptions in normal port operations and throughout the Delaware Valley estuary due to oil spills is a priority for the entire region. The Delaware Bay is the entrance to the largest petroleum port on the East Coast and second in the nation, with an estimated 1 million barrels of crude being transported through its waters on a daily basis. The Delaware River is home to 4 major refineries, numerous pipeline and logistics companies, and rail and shipping companies. Due to the deteriorating conditions of highways and bridge infrastructure across the U.S. and the added danger of shipping crude oil over the roadway via tank trucks, many companies have switched their primary method of moving crude oil to railcar methods. Railway transport of crude oil and other hazardous materials is expected to increase by greater than 88% by 2035 through studies conducted by the Department of Transportation. To put that into perspective, in 2008, 9,500 tank cars of crude oil were moved via rail, whereas in 2014, greater than 400,000 tank cars of crude oil were moved across the U.S. Although this increase in railcar use may come as a surprise, it's also important to know that over 99% of all railroad hazardous material shipments reach their destination without incident or accident. Bakken crude is a light sweet crude oil with an API gravity between 40 to 43 degrees and is similar to many other light sweet crude oils produced within the United States. API gravity denotes the lightness or heaviness of crude oils and other liquid hydrocarbons. Oil with an API above 30 degrees is termed light, between 22 and 30, medium, and below 22 degrees, heavy. In 2015, the EPA and the U.S. Department of the Interior conducted a test study of Bakken crude oil. The study discharged 660 gallons of Bakken crude into a tank. The sample was periodically tested as it weathered and analyzed for chemical and physical characteristics. The test was conducted at a temperature of 34 degrees and allowed to sit for 24 hours. Test results showed no LEL or lower explosive limit above 10%, with an LEL of 4.7%, 4 minutes after release. The test also showed oil loss of 20% in the first 5 hours, with Bakken crude dispersing readily. Types of railcars utilized. The primary type of railcar utilized in the transport of crude oil are DOT-111 cars. These non-pressurized tank cars have been utilized in the transport of materials over the railway since the 1960s, with each car having a maximum capacity of 34,500 gallons. Beginning in May of 2015, any new DOT-111 cars used in the transport of crude oil have been regulated to have increased safety features to reduce the incidence of product release in an accident. These new cars are known as CPC 1232 cars and currently are the only ones in use for materials being transported through Delaware County. Additional safety measures include increased thickness of head and shield to 9/16 of an inch, thermal protection, improved protection on top mount fittings, and lower outlet fitting protection to prevent outlet handle actuation during a train accident. Spill response strategies. Marine oil spill cleanup needs to be carried out in accordance with a clear strategy that takes account of the characteristics of the oil, the level of contamination, and the relative environmental, economic, and amenity sensitivities of different locations. Because equipment availability and manpower may be limited in the early stages of a spill, it's often necessary to prioritize sensitive areas, which can result in conflicts between, for example, economic and environmental interests. Marine oil spill cleanup is usually carried out in stages, starting with the removal of the heaviest accumulations of oil. Secondary cleanup ideally should not begin until heavy accumulations have been removed and the risk of recontamination by floating oil has receded. The need for secondary cleaning and the degree to which it is carried out must be judged against the economic and environmental sensitivities. In many instances, natural degradation processes deal with them quickly and effectively, especially where wave action and tidal water movements are strong. In special circumstances, for example, where beaches are heavily used by the public, final polishing to a very high standard may be justified, although some of the techniques which may be required can cause environmental impacts. Oil spill control. Oil spills can occur when there is a problem with oil handling facility/vessel transfer, when a pipeline ruptures or leaks, or when there is a transportation accident. Since conditions are different with each spill, different methods of spill control may be used. Mechanical containment and recovery is the most commonly used and most environmentally acceptable response technique to clean up oil spills in North America. Mechanical spill response uses containment boom to contain and concentrate floating oil, skimmers as well as synthetic sorbent materials to remove oil from the water's surface, and temporary storage devices to store the recovered oil and water until it can be disposed of properly. Some of the tools used to control oil in a spill include booms, which are floating barriers used to contain oil and prevent the spill from spreading. A boom can be placed around a tanker, rail car, or other vessel that has spilled oil. A boom can be placed as protection around or near an environmental habitat. Booms can also be placed around an entrance to a river, creek, or stream to prevent the spread of a spill. Responders can also use skimmers. Skimmers are configured to use pumps, vacuums, or belts to remove oil as it floats on water. The captured oil-water mix is then placed into a holding tank, such as a vacuum truck or barge, for disposal or further remediation. Sorbents are a sponge-like material that can collect the oil. Sorbents absorb oil when they are placed in a spill area. Sorbents are manufactured in several different configurations. Examples of sorbents include sweep, pads, and booms. Sorbent booms are also referred to as sausage booms. Spilled oil floating on the water's surface is affected by wind, currents, and gravity, all of which cause it to spread, fragment, and disperse. The first stage of an effective response is to deploy containment boom to limit further spreading and concentrate the oil for recovery. Containment not only localizes the spill, but also facilitates the effective removal of the oil by skimming or vacuuming as it concentrates in thicker layers on the surface of the water. Booms come in many different shapes, sizes, and styles, ranging from small, lightweight models intended for manual deployment on the river to large, robust units which usually need cranes and sizable vessels designed for the open water to handle them. Booms vary considerably in their design. The boom to be utilized should be flexible enough to conform to wave motion, yet sufficiently rigid to retain as much oil as possible. Most booms have difficulty containing oil in currents greater than 0.7 knots. The success of containment booming is dependent on currents, wind, and waves. Even minor currents can draw oil under the booms. Waves may cause splashover, and wind and currents may cause the boom to sink or plane. In winter conditions, even very low concentrations of ice can seriously affect the performance of most booms. Containment booms will quickly collect ice and subsequently lose oil as flotation chambers are submerged or lifted out of the water. It's essential that a boom be suited for its intended purpose. Containment. When oil is accidentally released into a body of water, the most urgent priority is limiting the spill's spread to minimize the natural resources at risk and to facilitate cleanup and removal. Swift and skillful deployment of a containment boom is essential for achieving both of these goals. Boom basics. Because oil is not as dense as water, it rises to the surface, where floating fences or booms can corral it. In its simplest form, a boom consists of a length of rugged fabric with buoyant filter stitched into the side, intended to float above the water, and a heavy chain or other ballast inserted into the bottom to weigh down the subsurface skirt. Boom material is brightly colored for ease of recovery and to help crews spot a break in the line. The freeboard, above-surface component is commonly designed to reduce splashover, while the skirt is engineered to keep oil from escaping beneath the boom. Under ideal conditions, a spill is quickly contained by booms strung end to end until they encircle or catch the floating oil. Realistically, a number of factors such as current, wave height, wind velocity, and oil viscosity steadily work to churn up the surface and hamper a boom's capacity to contain oil. The result is that during rough weather, some oil can splash over and flow under the boom. These conditions could require an additional layer of boom. Boom deployment. Each oil spill presents different challenges depending on the type of oil spilled, the location, weather, time of day, the manpower available, and the equipment at hand. It's important to plan a practical strategy to protect sensitive resources, utilizing the resources available and keeping safety in mind at all times. The effective and timely deployment of the oil spill boom can lessen both cleanup time and money. There are 3 types of boom deployment: containment, deflection, and exclusion. Open water containment. Before deploying any boom, response team members will assess the direction and velocity of the wind, water currents, and tidal timing to attempt to determine the best point of interception. Oil tends to concentrate against the boom in the direction of the wind and current. A small spill in calm weather along with minimal current movement can be contained by stretching a boom across a waterway perpendicular to the path of the spill. In the case of a crude-carrying tanker or rail car, boom can be used to encircle the floating oil so it can be contained and recovered. A deflection boom is used to deflect or move oil toward a more desirable recovery site. Deflection booming is a good option when currents are strong. To increase the boom's ability to contain oil, the boom is placed at an angle to the current. Angling the boom not only deflects the oil toward the shoreline where currents may be less severe, it allows for better containment and ease of recovery. Boom anchoring technique. Oil spill containment boom can be anchored in different ways. Generally, boom can be anchored on the shoreline, secured to a dock, or by free anchoring. Shoreline and anchoring to a dock structure are fairly simple once the wind and current are taken into account and finding a secure place to anchor. Free anchoring requires use of an anchoring system to anchor the boom sections in open water. Containment boom can be anchored from the end sections and at anchor points along the length of the boom. A standard anchoring system generally consists of Danforth-style anchors, marker buoys, hard-shell mooring buoys, galvanized chain, and poly rope. Sorbents. Sorbents work on 2 principles: absorption and adsorption. In most cases, sorbent materials are utilized to absorb oil floating on the water surface. They're used until they become saturated with oil and then recovered and disposed of, or squeezed free of oil and reused. Sorbents are not recognized or recommended as a primary means of recovering most oil spills because they float on the surface of the water and do not prevent oil from moving. The application and recovery of sorbent products is a labor-intensive activity, and the issues of disposal of oily sorbents are considerable. Unlike barrier booms, absorbent booms are lightweight, easy to deploy, and have the ability to help contain a spill and absorb oil. Sorbent-type booms work best in areas where the water is slow-moving. Due to the swift currents in many of our creeks, rivers, and waterways, the use of sorbent boom would have minimal impact on containment. They also require timely retrieval or an anchor point to prevent sinking as the booms become heavy with oil. Commercial absorbent booms are commonly made of an outer mesh with polypropylene filler and are engineered for easy deployment and maximum absorbency, as well as a long flotation period. Snare, also called pom-poms, nets, and multi-stranded sorbents are most effective on viscous oils and usually used to assist with cleanup of shorelines. Once containment of the oil has been achieved, the next step in the operation is physical recovery of the oil from the water's surface. Mechanical recovery. Mechanical methods such as skimming and vacuuming can generally be mobilized to recover oil. Because these techniques take place at the surface, they are subject to the same disruptions that applied to booms, particularly those posed by wind, waves, and currents. Skimmers are slow yet very effective equipment for surface removal in calm or sheltered waters and along shorelines. They take advantage of the adhesive nature of the oil, which will cling to any surface that it comes into contact with. Using various means such as rotation, suction, gravity, or other forces to drive motion, these machines provide a surface for the spilled oil to cling to and provide a continual process to clean oil from the surface. The primary types of oil skimmers include belt, brush, disc, drum. Skimmers float on the surface and are fitted with a brush, disc, or drum that collects oil as they rotate. The oil is then scraped off and discharged from the skimmer. In addition, a pump or vacuum device is necessary to transfer recovered oil and water to some sort of temporary storage tank or device. Vacuuming is generally utilized along the shoreline or at a dock where vacuum trucks have ready access. The vacuum truck works just like the vacuum in your home. Vacuum trucks not only recover but temporarily store recovered oil and transfer it to more permanent storage. Conclusion: although risks associated with the transport of crude oil over the waterways of Delaware County are ever present, the county, industry partners, and regulatory agencies such as the U.S. Coast Guard have worked to ensure that there are appropriate plans and countermeasures in place to ensure a swift, strategic, planned response to any incident occurring in which product enters a waterway.